And I should go live any second now. Okay, great. Welcome, welcome. So I got everything set up. Let me go ahead and pass my, well, I'm gonna go ahead and close this. Let me open a new tab and close the YouTube window. And I'm going to put my OBS on the other screen, my second screen. Finally, it looks better now because I have a table to place my OBS. It's not crashing anymore because I disabled the plugin that was buggy. All right, so we should be good now. All right, let's keep it moving. So let's go ahead and start my chat GPT. My desktop chat GPT is way better because it gives me more options versus the browser. And let me see if my recent chats, this one right here is the one I was working on. Here we go. All right, so let me open my VS Code. Okay, back on track. Great. Okay, so let me go ahead and run this over here. Wow, it does make a difference that I disable those plugins. Those plugins were definitely running a lot of processing power because the bugs were being in the way. So milestone 3, duration safe boundary planning. So I'm gonna go ahead and copy this and I'm gonna give it to my VS Code. And another thing, I want my other senior developer to be here with me, which is Gemini. I have three senior developers. I have my ChatGPT developer, my Gemini developer, and my Copilot GitHub Git Git Copilot developer, senior developers. So let me go ahead and pop out the chat. Great. Now, what happened to the other one? All right, that's fine. So now, let me give them the prompt right here. Let me X this out, press enter. Here we go. Let me minimize my terminal. Great. Let me get my previous chat. Is this the same one? No, it's not. No. I got the wrong chat window open. Hmm. That's not my last conversation. So let me X this out. And I'm going to go to my other account. This one here. I believe this is where my previous conversation lives. Yep. Mm, this one right here. No. Let me open up the other one. I think it's this one. Yeah, it's definitely this one. Yep. Okay, so let me pop up the chat. Let me maximize it a little bit. Something like this is fine. So now let's see what my senior developer is doing over here. So let's see what are my instructions from. What is my instructions from ChatGPT? So everything's good. The levels is good. The levels is good. Great. Water looks like I'm looking up. My laptop is like right there. But when I look at it, it looks like I'm looking up. All right, so this milestone is central to your original requirement. It ensures that later transcript and fallback analysis can suggest natural cut points without ever violating the strict 5-7 minute rule. Great. So now, hmm, what's missing here? Okay. First of all, I need this explained in a short version explanation. So I'm copy it, right? And my senior developer here is going to give me a small explanation of what we're talking about here. Please explain in short form. Because I gave him this prompt before. Let's see if he understands what I mean by short form. He's gathering the informations, still working. Okay, defining the boundaries. This task requires building a pure deterministic boundary planner that mathematically partitions a video total duration into clips strictly between 300 and 420 seconds, targeting 360 seconds instead of using a simple greedy approach that might leave an invalid too short final clip. You must use a global optimization algorithm like dynamic programming to evaluate and score potential cut points. The planner must first calculate if the video length is mathematically splittable, prioritize prioritize high quality natural cut candidates, and only inject penalize synthetic cuts when necessary. Finally, you need to write comprehensive unit tests for various edge case and impossible duration, various edge cases. Integrate this logic into the existing architecture and update the documentation, all without implementing the actual video cutting or external tools integration just yet. All right, cool. So that's what that means. Okay, let's see what my Git Copilot is doing. So he is now okay. I'm expecting the current planning related contracts and tests first, then run a baseline type check build before implementing a pure boundary. Looks like I'm shrinking again. It's all right. Mo Module and its integration points. I am gathering the exact current contracts and pipeline shapes now, so milestone 3 changes stay minimum and preserve existing behaviors where possible. I've confirmed correct contracts and placeholders. Next, I am running baseline validation commands now exactly as requested before changing planet logic. I am I'm ready to implement the planner module test now. DP-based global optimizers, candidate, okay, synthetic boundaries, and defensive validation against existing clip plan validators. I am implementing a planner in a new planning module. Okay. It exports to preserve, then wiring processes consume boundary candidates when clip plans are absent. Core planner and tests are in. I am now updating the pipeline surface. Okay, updating the README. Milestone planning behavior. All planned edits are complete. I am running a type check test build and I'll fix only issues introduced by mile 3 changes and report outcomes against a required checklist. So he's taking, oh, I gotta press play. Great. I gotta press play. Processing. So the test build commands will auto move to background before completion. So I am fetching the final output now to confirm pass fail addresses. Anything fails, and address anything fails. The capture output cutoff during the new boundary implement. So I am running. Okay. Why do I have to press play? Considering, or I see considering. Okay, so I found failure cause. The new broad a variant loop is too memory heavy and fights workers. I'm applying a minimum test only adjustment to keep deterministic broad coverage while preventing heap exhaustion. Then I'll rerun all validation commands. So I've reduced only the stress loop density and the invariance test. Now I am rerunning type check tests and build to confirm milestone 3 is clean and stable. So he's rerunning npm run build. Why are we doing npm build? Why would we run a npm run build if this has nothing to do with a distribution folder or in any case a website?
While your project isn't a traditional front-end website, the npm run build command is still necessary if your application is written in TypeScript. It compiles the source code into standard JavaScript that Node.js can execute, often placing these files in an output directory like dist or build. This ensures your code is ready for deployment or production use.
Okay, that makes sense. It's basically building it for deployment use, just like it said. So, uh, not sure if my camera is a little like low. Maybe it's a little too high now. Yeah, because my logo, what's going on? My logo is on my forehead. Let's see how that works out. So I've I've reduced only this. Okay, the suite is still running in one terminal session. I'm fetching the remaining output to capture final pass fail status. So it's still running. So let's see what he says here. I found the root cause, planner state explosion from generating many synthetic balance timestamps per recursive state. I am tightening the synthetic generation to a bond set. max plus an endpoint. A global planning remains deterministic and memory safe. I've applied a target fix to remove the memory blow-up path. I am running the full validation sequence now to confirm stable passing, test, and build. I've identified the remaining field. Those three expectations use boundary sets that can't satisfy the 300, 420 invariant for the chosen source duration. I am correcting those test inputs to feasible duration while preserving the intended behavior, natural preference, and dedupe. I've aligned those three tests with mathematically feasible duration. I'll rerun the required validation commands now and report final milestone 3 status, implementing milestones 3 with a pure deterministic duration safe boundary planner integrated minimally into processing flow and validated with comprehensive tests. So this is what's going on here. Okay, this is the contract. Extended boundary candidate source. Milestone 3 requires distinguished natural versus synthetic boundaries and support richer diagnostic. Pipeline contract was preserved, validate API. So I'm gonna go ahead and copy this again. I need him to explain to me what this means. So I'm gonna go ahead and ask him to explain this to me. Short answer, short form. So Gemini is going to give me a short form answer, which is what I've named. This is pretty much like a trigger. You successfully implemented the milestone 3 boundary planned. Planner using a dynamic programming algorithm that guarantees all generated clips strictly fit fall between 300 and 420. The system calculates mathematical feasibility of run, parallelizing and natural cut points, and only fall back to penalize synthetic boundaries to prevent invalid final clips. Your pipeline integration remains backward compatible or edge case and feasibility tests passed perfectly, and actual video cutting or transcription features remain intentionally deferred for future milestone. Great. All right. So we're gonna go ahead and keep this. No manual command is required beyond what was already ran. Did we did I paste this? Um well, let me paste it over here and see what happens. I'll paste it over here and see if it's the same results. Okay, good. So now, let me see what he means by OBS stats. Go to OBS view, stats. So 6%, FPS is 60, disk space available, average time to render frame. This full in approximately calculating frames missed due to rendering lag. 0%, that's good. Memory usage, skipped frames due to encoding lag, 0%, that's good. Output stream is live. Total data output, okay. Bitrate, that's fine, I guess. Recording, great. So let me just X this out. That means that we're in good hands. Based on my knowledge, first time use, and I understand it already. I believe I do. So let's go ahead and go over here. And I gave him the last report or the last response. All right. Let's see what he tells me now. He's thinking. He did tell me to keep this open though. Okay, let me do that. That's what he wants me to do. I am a very I I'm very serious about following instruction. I'll put it right here. I don't think I need this though. Let me see if I can minimize it. I'm not, I'm talking about the stats window in OBS, by the way. You guys can't see it because I have it. I have it as hidden. Invisible. Okay, that's fine. I got one view. This is better right here. Let me see. Actually, let me put it over here. Can I bring it over here? No, I can bring it over here. Sorry, guys, you can't see what I'm doing because I got OBS hidden. I just want to be able to. Okay, this is fine. Leave it right there. All right, cool. So let's see what was the response. Milestone 3 was successful. All 55 active tests passed. TypeScript compiled, and the project built successfully. What we just did in plain English, the application can now take a video's total duration and a collection of possible stopping points to then calculate the best complete cutting plan. For example, if a natural pause occurs at 6 minutes and another near 12 minutes, the planner can prefer those points. But it looks at the entire video before deciding. It does not blindly select one cut at a time. That matters because a locally attractive cut could leave a final clip only 2 minutes long. The planner now detects the problem. It moves earlier boundaries so every resulting clip remains between 5 and 7 minutes. It also understands that some durations are mathematically impossible. A 7 minute and a 1 second video, for instance. Oh, okay. Cannot become one clip of 7 minutes or less, or two clips of at least 5 minutes each. All right. So in those cases, it returns a clear error instead of violating the rules. So current application status. The application can now inspect and validate the real video. Read its duration and technical properties. Evaluate proposed stopping points. Generate complete global optimized 5 to 7 minutes clip plans. Create synthetic fallback boundaries when natural candidates are insufficient. Reject videos that cannot mathematically satisfy the durations rule. It still does not physically create the video files. The next milestone is fast forward and peg cutting, where the validated plan will be turned into actual MP4 clips. One architectural details to watch later. Pipeline can currently return either complete plans or boundary candidates. Ultimately, I prefer the transcript and fallback pipeline to produce candidates while one centralized planner owns all final timing decision. This reduces the change of inconsistent duration logic. It is acceptable for now because every return plan is still validated. Okay, so let's move on. Okay, so let's move forward. Reading is fundamental. I'm getting cold. Here comes phase 4. Wow, these prompts, this is definitely a skill prompt. What this milestone will do? So far, the application can inspect the video and calculate save cut times. This milestone connects the plan to fast forward MPEG. Afterwards, given a valid plan such as text. Clip 1 is 6 minutes. Clip 2 is 6, no, it's 6 minutes. Okay, to 12. That's another 6. 12 to 18. 12 is another 6 minutes. The application will create clip. Okay, perfect. It will not understand speech or choose natural pauses yet. It will simply prove that a safe plan can become real playable video files. Okay, great. So let's do that. We're gonna go ahead and copy this. Copy and give it to my co-pilot, senior developer, and we'll enter this. Now, I need to go to my guy over here so he can give me an explanation about this. Reading is fundamental, people. Okay, here's implementation for milestone 4. Secure and accurate fast forward MPEG video cutting. It strictly follows your architecture. Oh. Oh, stop. No, I mean, give me a short form explanation summary. Jeez. He was about to give me a 500 lines of code right now. I am ready for that right now. Oh, again? No. Oh. You're giving me code. You are giving me code. I am looking for. I'm looking to understand this prompt. And can you please explain it in short form? Maybe he understands now because he's doing too much. Let's see what my guy over here is doing. Okay, so he's doing his thing. I'll first inspect the current cutter, processor, test, and run baseline validation so milestone 4 changes. Stay focused on secure, fast forward, MPEG cutting only. I've confirmed the current cutters is still a placeholder in related contracts. Next, I'm running baseline tests before implementing milestone. Oh lordy, did he do this again? Yes, he did. Yes, he did. Yeah, he's messing up big time. Why you keep giving me cold? Honestly, he's stuck on stupid right now. Mm. Oh, he's following the prompt. That's why. Look at this prompt and explain it to me in one paragraph. Maybe this will work. If not, uh-oh. Yeah, he's stuck on stupid. Hey, so I keep giving you a prompt to explain, but you keep giving me the results of the prompt.
You're absolutely right, and I apologize for the misunderstanding. The prompt you provided for Milestone 4 essentially asks for the development of a secure and precise video cutting module using FFmpeg. The goal is to create individual, accurate video clips based on a validated plan, while ensuring safety by avoiding shell commands, handling file paths securely, and incorporating thorough error handling and testing.
Sure. Let's just put short. You have successfully completed a milestone by creating a secure production-grade video cutting module using no. The module securely invokes without shell commands, re-encodes the video precisely based on a validating dated plan, uses temporary files to prevent corrupt outputs, and implements strict error handling and timeouts. You also added comprehensive unit tests, an optional real media integration test, and updated the project documentation intentionally, leaving advanced features like AI analysis and a UI for future milestones. Okay. All right, let me give this a chat GPT. Let me see what he tells me. Not much. Milestone 4 is close, but I see one likely real world bug that mocked units test would not detect. The temporary output is described as clip 01 and partial. Fast forward MPEG normally determines the output container from the final extension. Here, the final extension is partial, not MP4. Why did it say partial? Let me see this. So fast forward may fail because it cannot determine the output format. A safer temporary name is okay. Alternatively, fast forward MPEG could explicitly receive dash f MP4, but retaining MP4 as the final extension is clear. Paste this targeted review prompt into Copilot. Plain English summary. Copilot built a component that takes our calculated timestamps and asks fast forward MPEG to produce a real MP4 file. It also added safeguards, so incomplete files are clearly temporary. All right. So I gotta make sure I can see my audio. I think that's fine, right? All right. They also added safeguards, so incomplete files are clearly temporary. Existing clips aren't overran. Failures are reported accurately, and clips are processed sequentially. The test passed, but those tests simulated fast forward MPEG. Before approving this milestone, we need to correct or rule out the temporary extension problem and then run one real cutting test. That real test will prove the application can physically create playable clips, not merely construct the correct fast forward MPEG commands. Okay, so let me go ahead and get this to me. Let me go over here. Control V. He's thinking. Okay, I'll make a narrow milestone for fix by checking the cutter temp path logic first, then patching only the temp file name, shape, and related test coverage before rerunning type check test build. Confirm the bug exists. Temp names are currently built as final plus partial, which produces a non-MP4 extension Yeah, because that's gonna be the extension. The last dot whatever is the extension. So for fast forward MPEG output, I'm applying a minimum fix to preserve on 10 files and updating test. Well, it looks like yeah. The 10 file gave me the test assertion or patch. I am now running the 3 required validation commands. Okay. I think I'm good. Let me copy this. Copy final response. I'm gonna go ahead and keep it. And I'm gonna give it to my guy right here. Um, press enter. I'm gonna sleep. All hungry. What are we to? So good catch. And fix. The temporary file name remains recognizable as MP4 and 073 active test still pass. So plain English summary, the cutter first writes each video to a temporary file. Only after fast forward MPEG finishes successfully does the application rename it to the final file name. Previously, that temporary file ended in partial. So real fast forward MPEG might not know what video format to create. It now ends in MP4 while still being clearly marked as partial. So test when to click OK. Oh, it goes from the partial to then, okay, now we need one real cutting test. Create a lightweight 10-minute test. Okay, so let's do this. Let's go to PowerShell. Because he wants me to, I'm gonna run this on my PowerShell right now. I don't think it's a problem. Okay, so now true. And now then enable and run the cutting integration test. This may take a few minutes. Actually. Okay. Ooh, fail test 1. This may take a few minutes because it creates 2 real 5-minute clips. Avoid running it during an important live stream. Although the low resolution source should keep the workload modest. Okay, I gotta give him this screenshot. It would have been nice if I could copy this stuff. Control Alt transcribe. So now let's see what he says. This is a test harness timeout, not evidence that the cutter failed. Vice default timeout is 5 seconds. Real fast forward MPEG encoding naturally takes longer. So Vice stopped waiting at approximately 5 seconds. Paste this into Copilot. So let's do that. So I'll make test only patch and the integration test to add an explicit per test timeout and strengthen clean up for partial files. Then I'll rerun the tests, type check test and build. I've applied only the integrated test timeout and cleanup update in the test file. Next, I'm running the request validation command. So it looks like if this is a long running test, pass a timeout value as the last argument of configured globally the test timeout. Okay, so we'll put this in here. I don't want to have to read all this. I'm gonna go ahead and keep it. And then after Copilot fixes it, rerun with the environment variable. Including 10 minutes of video into 2 clips takes longer even when even with your strong computer. We are adjusting how long the test waits, not hitting a cutter failure. If it passes with release of timeout, we'll know fast forward, MPEG, produce, and validate the actual clips. Let me run this now. Oh shit. Oh no. Okay, great. Control Alt screen. Success. Okay. All right. So what he says here: success milestone 4 is fully approved. The real fast forward impact integration test passed in about 11 seconds. 5 files passed and 4 passed. One unrelated fast forward probe integration test remains skipped. 0 failures, which is what we just proved. The application success is the application successfully. Open a real 10-minute video, use the validated boundary plan, created 2 real MP4 clips, confirm both output files exist and were non-empty, inspected the generated clips with a fast forward probe, verify their durations were close to the requested 5 minute 5 minute limit, cleaned up its test output safely. So the project can now inspect their video, calculate complaint, cut points, and produce actual playable clips. So let's clear the variables. All right, so the next phase is pipeline a local speech transcription. Before giving Copilot a milestone, let's check Python and NVIDIA code CUDA availability. Saving output that will help us choose between GPU acceleration faster whisper and a GPU compatible fallback without making Copilot install the wrong transcription stuff. Looking good, looking good. Levels are good, and I'm tired. Okay, GPU confirmed as 8 gigabyte RTX 3080, which is suitable for Celery Whisper. The concern is Python 3.14 AI package often lag behind brand new Python releases, so I am checking the current visual compatibility before. Uh, this is so now. The system is suitable for local transcription. Python. Okay. Okay. Current C Translate 2 provides Windows wheels for Python, while FastOrder requires Python 3.9 or newer. So we can keep your install Python rather than adding other versions. So support GPU. For reliability, we'll design CPU fallbacks, GPU mode for milestone 5, local whisper transcription. Give them this. What this as application ears? It will listen to a video locally and produce timestamp tests such as I'm hungry. So, I'll be back. Alright, I'm back. Let's see what he did. Oh, he's still working. Oh, okay. I spotted a formatting artifact in the newly added integration test file, and I am correcting it now with a tiny cleanup. You guys don't gotta see me eating. With a tiny cleanup patch before continuing. Actually, why not? You wanna see me eating? Oh, very unprofessional. Wow. These are Dockers? What is he creating here? PY. Hmm. Uh-oh, not the create file conflict. And existing requirements. I'm updating that existing file. Uh-oh. Hmm. Get an error. I don't normally eat cornflakes, but when when it calls for it, I'll eat it. I eat some cornflakes. It's been years since I've ate cornflakes. By the way, we call all cereals cornflakes. I'm Hispanic. Got it. Cornflake. All right. TypeScript side is now clean. I am checking whether a suitable local Python V environment with dependencies exists so I can decide. Okay, I gotta press allow. All right. He's working his ass off today. I've never seen him work so hard. Okay. Wow. And this is probably one of the most important phases because they're going to listen to my voice on the video or audio and then make a wise decision. Let me paste this over here. This adds the application to is it will listen to a video locally and produce timestamps tests such as. Oh, okay. Welcome to today's discussion. First, we'll explain the main problem. Oh, look at that. I could have actually, let me see something. Let me see something. Let me go to my YouTube videos. Let me go to my channel real quick. I'm gonna look at my timestamps. I could actually break down the videos based on the timestamp. Look at that. You live and learn, people. Let me look at my videos. Let's say this is live. I don't want to see the live videos. Let me say I pick one of the old ones, right? I don't want it to play just yet. I click on description, right? You see? Wow, I could have done that. Promoting variable scope and apps.js. And that one just lasts 2 minutes. So easy. Wow. This is how long is this video? 21 minutes. I could have easily done that with the timestamps. Look at the titles. Avoiding shadowing by replacing local lat. Alright, whatever. Now I know something new. I might use that as a way for me to create my short clips or to create the clips. Okay, so it won't decide the cuts yet. The following milestone will analyze those timestamps, ideas, and turn natural conversational endings into boundary candidates. Okay. So now what? I give them this. Okay, let me press enter now. Looking good, I guess. No complaints here. Milestone 5 is structurally complete, but it's not fully approved yet. The node adapter passed, while the Python worker itself has not run because its isolated Python environment is not installed. What we just built, the application now has a secure bridge between Node.js and Python. Node creates a transcription request. Node launches the Python worker without using a command shell. Python loads faster Whisper converts speech into timestamp text. Python returns to clean JSON. Node validates every timestamp before accepting it. The test currently proves the bridge handles simulated worker response correctly. They have not yet proven that the actual Python worker imports and runs. Create the isolated Python from the project root. Run these commands individually. Let me see something again. Oh, really? I want to see. I want to see one of my longer videos and see if I have timestamps there. So my videos. Let me see. Like this one, for example. Let me look at this. Go to more, and it has timestamps. Here it is. So the first 12 minutes is project initialization. Wow. So then the next one is 12. It's 20 minutes. So in 2 minutes. The third one is like 10 minutes. The fourth one is 10 minutes. The fifth one is 20 minutes. Okay. Hmm. That's pretty cool. Okay, so next, let me close this one for now. Next. So we got to run these commands individually, all right? Let's do it. Uh-oh. I keep putting it in chat windows. Always happens to me. Control C or Control Shift. Backtick, yes. Control V. Alright. So froze. There it goes. And then the third one, upgrades, upgrade environment packaging tools, install runtime dependency, setup tools, wheels. Okay, good. No vulnerability. Right? Okay, so this one is install development test dependencies. Let me see. Run the Python units. Four. 1, 2, 3, 4, 5. 5. Run the Python unit test. Using the virtual environment, Python directly avoids PowerShell activation policy problems. Expect the results. All Python unit tests pass without downloading a Whisper model because they should use a mocked model. Do not enable the CPU or Coda integration test yet. First set. First, send me the installation output and Python test results. Then we'll create a short speech sample performed one real local transcription, including the model download and GPU runtime. Okay. I already ran the CPU coder. What is this? Control Alt, Control Alt. Wait a minute. Let me do one of these. Oh, it's just press Control or become a. It created a test file. Okay. Okay. I'll read the attachment terminal transfer and inspire whether environments that are complete or where it's stopped. Why is it doing that? I can see the attachment reference, but the Windows command runner is blocked from opening. It accesses the full PowerShell stats. Please paste the terminal output directly into the chat, especially everything after. Python VEM. Python VEM. Let's just press Alt, Control Alt. I think there's a way for me to show previous clear run. I don't know why. Hmm. Hmm. Okay. Oh, makes sense. Oh, I see what they want me to do. I'm just gonna put in my notepad so I can kill. Oh no, you can't. It has to be three backticks. So they want me to convert it to come make sure that is written in text. So no, that's not gonna work here. Please copy its content, paste them directly into your message inside a code block. Okay. Don't use. Okay. Oh, okay. That's the problem. Attach. Don't use attach as file for this one. Once the terminal text appears directly in the chat, I can diagnose it immediately. Okay. TXT. Shift enter. And then. Oh. Show in text field. There you go. Switch my legs, but okay, success. The Python environment and worker are now validated. Virtual environment created correctly. Fast Whisper and C Translate 2 installed successfully. Python 3.4 compatible package install. All 10 Python tests passed. No Whisper model was downloaded during the unit test. The JSON visible between the dots is test output from exercising the worker's command line protocol. Is not a hidden. What we just proved, we proved that the actual Python code can load, is installed dependencies, validate transcription request, produce timestamp transcript JSON, return structure error for invalid request, select CPU configuration correctly in marked condition. We have not yet translated your speech. Let's do a CPU smoke test first. Run these commands separately in the Windows show. Control copy. Getting tired. How many of these do I have open? Control shift back, take Control B. Okay, not a problem there. Oh, number 2. We're going to create a variable. We're going to declare as a new object. And we're going to assign it to, we're going to assign speech synthesizer. Okay, so the first, this is number 1. Did I do that one? Yeah, number 2. Number 3. Number 4. 1, 2, 3, 4. Falling asleep. Wow, that's a lot of breakfast. Welcome to the Smart Video Clipper test. This application. Okay. Dispose. Okay. Confirm it exists. Oh boy, I'm falling asleep now. Okay. Use a smaller, tiny model for this first smoke text. Okay. Oh shit. Okay, I'm gonna do this, come on. The first round will download the model and therefore take longer. If it passes, we know the application can for generate local speech text. Then we'll clear those variables. Guys, I'm falling asleep. I don't know if I was drinking coffee. There's some coffee back there. It's cold. You see, the errors expected for the test are not. It was per failure. The file was per speech contains only audio only. The application correctly rejected it because the main product processes video and its probe requires a video stream. Convert the speech sample to a small. Okay. Second one. Oh my god. Third one. Here's the third one. Path. Yeah. Oh, one time. NPM text. No text. Oh, wow. Oh, man, sorry. Just right here. I'm tired. Another arrow. I'm gonna give him this one more time. If not, then I'm trading him for both of them. I knew this was gonna be a problem. It usually is. Thing, I'm going to not show my face. I'm sleepy. This video is now accepted, but was failed while downloading the tiny model. The application currently converted the underlying content failure into a safe type, but that safe message hides the technical cause we need to diagnose. Run this. Okay, guys. Man, one more, baby. That's it. I'm done. We found the exact cause. Module not found. No module name request. This is not model CUDA or video prompt. The install imports the request package, but the project dependency file did not install. Fix. Copy here. Control shift back to. Oh shit. It's supposed to go in here. Oh man. We'll try it. Looking good, looking good, looking good. The hurricane did exactly what it needed. It exposed a missing hidden behind the replication save URL message. Our request is installed on a recording. We can retry model download before running. Alright guys, it's time for me to take a nap. As soon as I wake up, I'll come back to this. Probably be like in 3 hours. Thank you. Oh man, I'm so sorry.